In this video, I'm going to be talking about 6 to 4 tunnels for IPv6, and this transition technique is an automatic point-to-multipoint tunnel. So here's our topology. We have 3 IPv6 networks, and it's running over the public internet. Well, not public because we're using 10s right here, but I'm using GNS3 to show this. But the underlying infrastructure is IPv4. So we want to connect these IPv6 networks together, and it is going to be a point-to-multipoint topology here. So I have the configuration set right here, so when I configure it, we can do it together. And I'm also going to show you how this automatic tunneling works, and I'm also going to do some packet capture so you can see the encapsulation of the IPv4 addresses. So let's get right to it. And R2 and R3 are already configured, so I'm going to configure R1, and these are the steps that we are going to, the configurations that we are going to do. So let me bring up R1. So first thing is we are going to create a tunnel interface. So go into config T and we'll go interface tunnel 0. All right. Then we are going to do IPv6 address and then give it a IPv6 address that is derived from this IP address right here. And I'll get into that. Let me configure this and then I'll go into how we got that address right there. All right. So IPv6 address 2002, we'll go A00:101 with a prefix of a 128. That's fine. Then we'll do a tunnel source. Tunnel source is the actual outgoing interface of our router. So we could either do the actual interface itself, which is FA00, or we can give it the IP address of what it is. So I'll just give it the IP address of 1.1, and then the tunnel mode, of course, is going to be IPv6 6 to 4 because we're doing 6 to 4 tunneling. All right. Why didn't that work? Tunnel mode IPv6 6 to 4 6 to 4. Why doesn't it want to work? That's why it wasn't working, because the syntax was wrong. Duh. Let's get back into it. What was it? Tunnel mode IPv6 IP 6 to 4. Huh. All right. Now that's good. Now you can see it's doing some it was doing some crazy thing right there, but that is actually it going out and trying to find other tunnels out there. So also what we have to do is we have to do some static routes so we can tell. So we have to do some static routes for tunneling. So one of the restrictions for 6 to 4 tunneling is you can only use static routes in BGP. So here we are going to actually run static routes. So let's configure that right now. So we'll do IPv6 route, and then how do we get to those IPv6 networks? So we'll go 2001, what is this, DB8:2, and it is going to be a /64, and of course this is going to be the next hop address. So these are the going to be the tunnel IP addresses of R2 and R3's IPv6 address. So this is what we have to do here. : and let's change it. 3? No. 3, and that should be 3. And then everything else, if it's going to be destined to a 2002 address, we are going to use the tunnel interface. So IPv6 route 2002/16 prefix, take tunnel interface 0. All right. So everything is set. We should be able to ping a interface here, or at least the IPv6 network. So let me ping R3 right now because that is the network. So let's ping it. Actually, we may lose a couple packets due to ARP, but let's see. What 2001 db8:0:3:1, and let's source it from my IPv6 address. I think I did loopback one. Loopback one. All right, let's see what happens here. We are pinging. Lost one packet. We lost two. Come on, you can do it. All right, we lost three, so we got 2 ping packets, and we ping it again. It is 5 out of 5. All right, so let's do some explanation right here. So how does IPv6, this tunnel, the 64 tunnel work? Well, first of all, the prefix for a 64 tunnel for the address has to be 2002. That's it. And then after that, the next 32 bits is going to be the IPv4 public IP address. So of R1, you can see here, it is a /30 on a 10.0.1.0 network. And I wrote it out in binary so we can see what the hex address is. So 10.0.1.1, you draw it out in binary, and it looks like this. And the way that the IPv6 address is derived from, one hexadecimal digit is 4 binary bits. So if you just separate it into 4 bits, you can easily get the hexadecimal digit here. So that's what that is. So 10 in hexadecimal is 0A because the first 4 bits are all zeros, and then this right here equals 10, and in hexadecimal 10 equals A. So that's where that came from. And then just go ahead and just separate each of these bits into 4 bits, 4-bit sections, and then that's what you get. So that's why we have A00:101 as the IPv4 address, or the IPv6 address that was derived from the IPv4 address. All right, so let's actually do some packet captures to see how it is actually addressed. So I'm going to start capture, and we'll use the cloud, which is R4's Fast Ethernet 1.0 interface. Let's start that up. And Wireshark is way too big, so I'm just going to keep it right there. Let me clear everything off. And let's do some packet captures. So let's go ahead and let's reping that. Bam, look at all that. All right, so let's stop packet capture because the pings already went through. That's good. Let's go back into GNS3 and let's stop capture. And let's look at this. So we did some pings for IPv6. So here you can see the source IP address and destination IP address. Looks like it is IPv6. Well, the cloud doesn't understand IPv6. That's right. So let's actually break it down. So here we can see the layer 2 address. Why won't it expand? There you go. So there's the layer 2 address. That's cool. But we can also see, why doesn't want to, anyways. Here we see the IPv4 address of our destination because that was derived from the actual tunnel interface that we set up. And if we can close this, how do we collapse? Collapse all. So here we have 2 IP headers. So we have an IPv4 header and an IPv6 address header as well. So this is how the packet knows to get to its destination because the IPv4 address right there. So that is how IPv6 64 tunneling works. I hope this was informative for you, and I'd like to thank you for viewing.